Today I'm going to show you what happens when you change your blade and don't adjust for the blade's thickness, and how the Arbor Shims solve that problem. We need to understand the importance of maintaining a constant zero cut line. Here's why. You see, every blade cuts its own curve, and regardless of the thickness of the blade, vibration and warping can cause the runout to change over time. So every time you change your blade, you're actually changing the distance between the blade and the fence, which makes your cut inaccurate and can cause your riving knife to bind up, which is very dangerous. Now that you understand what the Arbor Shims do and why you need them, let's go ahead and set them up. Now, one important thing to note before we get into this is that the setup for these Arbor Shims is different for left tilting saws than it is for right tilting saws. For left tilting saws, you start with your widest blade, and that'll be your default blade. And for right tilting saws, you start with your thinnest blade. Again, for the purpose of this demonstration, please note that this is a left tilting saw with the fence on the right side of the blade. We're going to start with our thickest blade, and that'll become our default blade. And based on this blade, we're going to calibrate our rip fence and our riving knife. Now, this is something that a lot of people don't think about, never occurred to them, it never occurred to me. And that's that where your blade is mounted on the arbor has its own specific runout. So changing the blade's rotation and its orientation on the arbor could change the curve that it cuts. To make sure that your runout is consistent, you want to make sure that your blade is always mounted on the arbor in the same orientation. Now, before you go sticking your hands in the saw, make sure you unplug it. That's very important. All right, so we're going to raise our blade up, and we're going to make a mark on the arbor and on the blade right next to each other, so that you know whenever you take your blade off and put it back on, you line those two dots up and you know that your blade is in the same orientation as it was when we calibrated the saw. We're going to calibrate our fence scale and our riving knife based on this default blade and how it is currently mounted on the arbor. The first thing that we're going to do is we're going to set up our riving knife. And to do that, we set our fence scale to 5.5 inches. We're going to make one that's 18 inches long, and then for each blade that you want to set up, cut another piece that's 8 inches long. For this setup, we're going to use 3/4 inch MDF, and the reason we use MDF is because it's not wood, it's an engineered material, so it's not going to swell or bow or warp over time. So when we're calibrating a fence, we don't want this to change at all. And remember, guys, always wear eye protection, always. We need one of these pieces to set up our riving knife, so we're going to make it 18 inches so that it sits on the table both in front of and behind the throat plate, because we don't want it falling into that hole while you have it open. Now, it's very important that once you cut these test pieces, you don't move the fence. We're going to base all of our calibrations on this cut, so don't move it. In the meantime, I'm going to take this over to the chop saw and cut it to 18 inches because I don't want to move that fence. All right. Here's our 5.5 wide by 18 inches long scrap piece that we're going to set up the riving knife with. So we don't get confused, we're going to write riving knife setup on this. While I'm at it, I'm going to go ahead and cut the other test pieces I need. You need one for each blade, and you're going to cut them at 8 inches long. All right, look at that. We can set these pieces aside for now. We'll get to that in a minute. All right, I'm going to remove the blade so that I can calibrate the riving knife. And we're going to take the riving knife setup board that we cut, and we're going to slide that up toward the riving knife. So all we do is we loosen the bolts that secure the riving knife in place. So with this board tight up against the fence, just apply a little bit of pressure on your riving knife so that it's tight up against this board, and then tighten it back down. All right, we can see that the riving knife is tight up against this board, which means that it's perfectly calibrated with the fence side of the blade, which is right where we want to be. All right, now we can put our blade back on. Remember, at the beginning we made marks on the arbor and the blade, so when you're putting it back on, make sure that those dots line up again so that it is in the correct orientation. Now, with one of the 5.5 inch wide by 8 inch long pieces, we're going to set up our fence scale, and we're going to mark it 5 inch scale setup. Okay, now you can move your fence. We're going to move it to 5 inches, and we're going to rip this board and see how far off we are. Again, safety first, use those glasses. Using a digital caliper, we're going to measure the width of this board and see how close to 5 inches we actually are. All right, I'm right at 5 inches, but that's because I calibrated the saw yesterday. However, if you're a little bit over, Just nudge your fence in a little bit, make a few cuts until you land exactly at 5 inches. And once you make a cut that gives you a caliper reading of exactly 5 inches, then you can move the cursor on your fence scale. Caliper says exactly 5 inches, so I need my fence scale to say the same thing. All we do is loosen these bolts, and then we move our cursor to exactly 5 inches and then tighten it down. All right guys, your riving knife is calibrated, your fence scale is accurate. It's time to set up our arbor shims. As I mentioned earlier, you need one 5.5 by 8 piece board for each blade you intend to set up. The first thing that we do is we're going to draw a line down the middle of each one of these boards. On the top half of each of these boards, write 5-inch default blade. Like so. Now you're going to take the boards that have the line down the middle, put it on the table and up against the fence, and then take your scale setup board, put it on top of that. We know that that's 5 inches, so we're just going to register off of that. All you do is you just trace a line at the bottom of the scale setup board, and this thin line right here, that is our zero cut line. That's where we want to end up. Next, we're going to use these boards that have the line down the center, and we're going to rip them halfway up to that line, and then stop and pull it back. You'll see why in a minute. What we're doing here is cutting a portion of the board with our default blade so that we can see our zero cut line. And as we change blades and we cut it the rest of the way, we can actually see and measure the difference between the two blades and know how many arbor shims we need to use. All right, now that we have all these cut, we're ready to change our blade. Remember, don't move this fence. The fence is exactly where it needs to be. And for this demonstration, we set it up at 5 inches. It could be at any length, but we set it up at 5 inches so that you would have enough room to change your blade comfortably. For the purposes of this demonstration, I'm going to use a Forest ultra thin kerf blade so that you can see how vastly different this blade is from our default blade and why you need the arbor shims. Okay, in this setup process, each time you install a blade, locate the mark on the arbor and make a corresponding mark on the blade. With a new thin kerf blade installed, we're going to cut the second half of this board so that we can see the difference in the kerf and determine how many arbor shims we need to install. After cutting through the rest of this board, you'll see that the difference between our thin kerf blade that we just installed and the default blade is pretty big. It's pretty far away from the zero cut line, and you'll also notice this gigantic step here. That's the difference that our arbor shims need to make up. Not only that, it was difficult to get through the entire cut because when I changed to a thinner blade, that moved my zero cut line further away from the fence, which gave me a wider piece, and there's not enough clearance between the riving knife and the fence for it to go smoothly. I was able to get it through the cut, but it was difficult, there was a lot of pressure, and it's kind of dangerous. Now, since we're dealing with thousandths of inches, we're going to need to use a digital caliper to measure the difference between the default blade and the thin kerf blade so that we know how many arbor shims to use. After you verify with the caliper that the top half of your board is exactly 5 inches, zero it out. Now measure the bottom half that we cut with the thin kerf blade. The number that you see here on your caliper reading represents the difference that we need to make up in arbor shims. This happens to be 32 thousandths of an inch, so we need to combine shims to get the appropriate thickness to make up that difference. The set comes with 6 arbor shims, the thickest of which is 20 thousandths of an inch, then it jumps to 10 thousandths of an inch, then 6, 5, 4, and 3 thousandths of an inch. To correct the difference between the default blade and the thin kerf blade, we need to use the arbor shims as a spacer between the arbor flange and the thin kerf blade, moving it out 32 thousandths of an inch toward the fence. So we can remove our blade, install the shims, and cut it again, and we'll see that that zero cut line has matched with our default blade. And when you install these shims, they go on before the blade, and you start with the thinnest on the inside, and you move to the thickest on the outside. Remember, when you reinstall your blade, you need to make sure that those dots line up so that your blade's in the correct orientation. All right, arbor shims are installed. Let's cut that board again to see the zero cut line match up. And success. So I cut it again, and by putting the arbor shims on the back side of the blade, that brought my blade out to the zero cut line. At this point, we can remove our blade and repeat that process for every blade that we want to set up. Before you move on to the next blade, take the blade that you just set up and mark the difference that you need to make up in arbor shims. As you're setting up your blades, it's also a good idea to write it down elsewhere so that if your blade gets worn or scratched, that you don't lose that measurement and have to set it up all over again. The Blade Match Arbor Shim system from MicroJig. Different blades, same cut, every time.